All right, here we are, last quiz of the year. All right, so for this first one, we are given a formula for the nth derivative. So if we want first derivative, second derivative, third derivative, whatever, we have that formula there. We just plug in n for which derivative we want. What is the coefficient for the term containing x to the fifth? And this is g, not f. So we want the fifth derivative, at 0, since it's Maclaurin, and then over 5 factorial. That's going to be your coefficient for your x to the fifth term. So we are going to plug 5 in. 5 is n for this. 5 plus 1 is 6. Since that's even, this is going to be positive, so I don't really need this part. That's going to be 5 factorial over 6. And then that's over 5 factorial, which you can put that over 1 if that helps you to think of it. When you're dividing by a fraction, you multiply by the reciprocal. So we're just going to flip this over. The 5 factorials cancel, which is kind of convenient, and you get 1/6. So we used 5 because it was the x to the fifth term. And then 0 here because it's Maclaurin. But that actually didn't end up mattering because all we had to plug in was n, not x. All right, find the fifth degree Maclaurin polynomial, so again around 0, for sine of 2x. There's 2 ways you can do this, the short way and the long way. The long way is off to the side. You're going to have to write out your first through your fifth derivatives, and then do your whole big long formula. The other thing you can do is if you memorize your expansion for sine of x. And so it looks like this. And I'm going to stop on this term because it said to the fifth power, the fifth degree. And then we are just going to plug in 2x everywhere we see an x. So this one's just going to be 2x. If you cube 2x, 2 cubed is 8. X cubed is just 8 cubed. And then if you take 2x and take that to the fifth power, 2 to the fifth is 32. So 32x to the fifth, and then over 5 factorial. So much shorter if you have that memorized. I have memorized sine, cosine, and e. Those are the 3 that I know. You can certainly memorize all the ones on that little half sheet that I gave you, but I would at least memorize those 3. They come in real useful there. You don't have to do all that work to find all the derivatives. Not that they're that hard. But. All right, using the information in this table, we have the first, second, third. We have the function, the first, second, and third derivatives. We may or may not need all of them, though. Sometimes they'll give you a table that goes further than you need it, so just make sure you read. We are going to need them all. The first 4 non-zero terms in the Taylor series centered around x equals 2, and I know it's 2 because we have x right there. All right, so this is going to be 3 over 0 factorial, x minus 2 to the nothing. All right, and then we're going to do our first derivative, so negative 1 over 1 factorial, x minus 2 to the first, and then plus 1/3 over 2 factorial, x minus 2 squared, and then plus 3/4 over 3 factorial, x minus 2 to the third. And I didn't print it on here. I would like for you to simplify this down, okay? 0 factorial is 1. Anything to the 0 power is 1. So that first term is just 3. This is going to be minus 1 over 1. So that's going to all just go away. So minus just x minus 2. 2 factorial is 2 times 3 is 6. So 1/6 x minus 2 squared. And then I'm going to just do a little margin problem for this. This is 3/4 over 6. Just do this off to the side. I'm going to put that over 1. So it would be 3/4 times 1/6. That would be 3/24. That's going to reduce to 1/8. Lots of different ways you can do that. If you can hold it in your mind, that's cool. I just did a quick margin problem to work it out. All right, find the third degree Taylor polynomial centered at 3, and this is our function. That is another one of the ones I think that it was on that little half sheet that you can memorize. To be real honest, I don't have that one memorized. I memorize sine, cosine, and e. Those are the ones that show up the most. So those are the ones that I have memorized. This won't be too difficult to take these derivatives. I stopped at the third one because it said third degree. So if you think of this as x to the negative 1, you would bring that negative 1 down. It would drop to a negative 2. Then this is going to be positive 2 over x to the third. You want to think of this as 2x to the negative 3, so that'll be negative 6 over x to the 4th. After you do enough of those, you can see that pattern show up. It's just not that bad to take those derivatives. So let's see, we want to plug 3 into our original function, so 1/3 over 0 factorial x minus 3 to the 0. All right, and then the next one, if we plug 3 into our first derivative, that's going to be negative 1/9 over, I'm using smaller lead and I keep breaking it, over 1 factorial x minus 3 to the first. All right, and then our second derivative, if we plug 3 into that, we're going to get 2/27 over 2 factorial x minus 3 squared. And then the last one, if we plug 3 into that, the way I remember 3 to the 4th is 81 is 3 squared squared. 3 squared is 9, and then if you square again, that's 81. So negative 6 over 81 over 3 factorial x minus 3 cubed. And then I do want us to clean that up a little bit. This is just going to be 1/3. This would be minus 1/9 times x minus 3. This is just 2. If you multiply that by 27, 2 times 27 is 54. And then conveniently here, 3 factorial is 6. So these 6's are going to cancel. It's going to be minus 1 over 81 x minus 3 cubed.